Dear students, I am Nilanjana Sanyal. Welcome you all to my channel NS Online Math Classes. Our today's topic is solving quadratic inequalities by sketching a parabola. This is also known as the graphical method. This is the part 1. We will be having another session on this particular topic. And this is the last method that I'll be discussing about how to solve quadratic inequalities. Previously, we have learned how to solve quadratic inequalities using the algebraic method, also known as the product properties method. We have solved quadratic inequalities by the sign diagram or the number line method. We have learned how to solve quadratic inequalities using the sign chart or the sign table method. Now we have come to the fourth method of solving quadratic inequalities. This is the graphical method, and quadratic expressions when graphed will be giving us a parabola. So I have just written solving quadratic inequalities by sketching a parabola. Okay. So without any further delay, let us start with our today's session. First of all, let us know what is the question for this today's session. Okay. The question is solve x square minus 2 is less than x. Next, as usual, we come to the rules. Bring all the terms to one side of the inequality sign. So we will be bringing the x to this left hand side because, as I have said, I always prefer to keep the term containing x square as a positive term. Okay. So I have brought this x to the left hand side and the expression or the inequality becomes x square minus x minus 2 is less than 0. Point number 2, rule number 2 says factorize the expression and get the zeros or the critical values, because there isn't the equality sign included. So strictly speaking, they will be the critical values. But first of all, we have to get the factorized form. It is x plus 1 times x minus 2 is less than 0. And then we come to the critical values. We call the zeros the critical values when the equality sign is not included. But loosely speaking, even now we can call them as zeros, and we call them as zeros even when the equality sign is missing. Okay. So, but strictly speaking, they are the critical values, x equals -1 and x equals +2. Rule number 3 says, sketch the parabola by plotting the zeros. You will be having the x and y axis and you have to plot the parabola. We are having the two zeros or the two critical values, and so these two will be the 2 points on the x-axis. The point corresponding to x equal to -1 will be -1, 0, and this one will be 2, 0. So we are having the 2 points which will be plotted on the x-axis. And how do we plot the parabola? How do we sketch the parabola? We do not know any other point which lies on the parabola, but this is sufficient. It will open upwards. If you have seen the parabola, the shape of a parabola, it is of the shape of a U, the English alphabet U. So it will open upwards if the term containing x squared, that is this one, is positive. Else it will open downwards. Since it is a positive x squared, so this parabola will be opening upwards. Okay. So this is the number line. I have not marked any number on the y-axis because I do not need them. But I know there will be the 2 points on the x-axis. Those will be the -1 and the +2. And the parabola will be opening upwards because the term containing x squared is positive. So the U is opening upwards. See, it is not at all a perfect shaped parabola, but that is not required. You just draw a rough sketch. You have the zeros or the critical values, and you have to just know whether the parabola is opening upwards or downwards. That is important. So you just get the 2 points and connect those 2 points with a U-shaped thing. And you have to keep in mind which direction is the U opening. That is all that is required. Okay. And then the next one is select the region or regions below the x-axis for less than sign. In this case, there is this less than sign. We will be selecting the region which is below the x-axis. That is this part. Okay. Or if it had been the greater than sign, we would have taken the region above the x-axis and include the zeros for equal to. If we have the equality sign included within this inequality, then we will be including the zeros. But these are critical values. These are not zeros because the equality sign is not included. So we will not be taking the -1 or the +2 in our final answer, but we will be taking this region which is lying below the x-axis as our final answer. Okay, so this is the final answer. X is greater than -1 but is less than +2, because any value of x that you take between these two values, -1 and +2, will be giving us a negative product. If we take 0, 0 is a value of x which is lying between these two numbers, -1 and +2. If we substitute 0 over here, we get 0 plus 1 is 1 and 0 minus 2 is -2. 1 times -2 is -2, a negative number. It is a negative product. So it is less than 0, which is required. So instead of 0, if you take 1, 1 plus 1 will be 2 and 1 minus 2 will be -1. 2 times -1 will be -2, again a negative number. Whatever value you take lying between these two numbers, -1 and +2, you will always be getting a negative number as the product. So this is our final answer. X is greater than -1 but is less than +2. Or else if you want to write this answer in interval notation form or set interval notation form, you have to write it in this case, in this way rather. X belongs to, these are the two brackets which imply that these values are excluded. -1 is excluded as well as +2 is excluded. So x can have any value lying between these two numbers, -1 and 2, but these two numbers are excluded. Okay. So students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.